Welcome to the third video in the Ansible for Network Automation series. In the previous videos, we downloaded and installed all the components that you see listed here, and then by the end of the last video, we were able to start automating. And in this video, we're basically just going to keep going with the automation. We're going to start with ad hoc commands right where we left off. So before shutting everything down last time, I did save the configurations on the routers and switches, which is what you have to do in order for the configurations to still be there when you boot everything back up. So I've fully rebooted my computer since then, reloaded everything, and there is something in the network automation appliance that is not persistent through reloads, and that is going to be our etc.hosts file. And you can see that our IP address to hostname mappings are no longer in there. So what we have to do is go and configure it again. So nano etc hosts to get into the file. All right, and now you can see that it is back and configured correctly. And then we'll just do some connectivity tests to make sure that everything's still working. Okay, so we can ping everything. See if we can SSH. Okay, so. And then real quick, I'll test the other ones as well. All right, so we can still ping everything and still SSH to all the devices, so we should be good to go. All right, and just as a review, this is the first ad hoc command that we ran, which is running against only the R2 device. We're using the raw module. We're executing a show version. The user, the -u, is specifies the username we're going to use, and K basically just says to prompt for an SSH password. Password Cisco. All right, and then all of this output is the show version from R2. Okay, I'm going to do one more setup configuration task, and that's going to be adding point-to-point networks between routers 2, 3, and 4 here. And then I'm going to turn on EIGRP so that EIGRP routing works between these. And the purpose of this is just to have some EIGRP neighborships and routes and that information to query from the network automation device. All right, then all of this configuration here is what I'm going to be copying into the devices. So basically just adds point-to-point networks. So this is going to be all the information that I'm just going to be copying into the devices. It's going to be adding point-to-point networks between the devices. Each device is going to have a loopback that's all going to be in the 10 network, and then I'm going to be turning on EIGRP for interfaces that have IP addresses that start with 10. All right, so you can see that R3 can see all of the loopbacks here, so that's what we want to see. And then R2, and then R2 can ping through R3 to R4, which is what we want to see. All right, so that should be good. All right, so this is going to be the next Ansible Ad Hoc command that we use here. So I'm just going to paste this in. And again, this is going to be used on the R3 router using the raw module show IP EIGRP neighbor with username Cisco and prompting for the password. And then you can see there it has returned the two EIGRP neighbors. All right, so in our previous commands, we were using it against only one device. In our next command, we're going to advance that and use it against a group of devices. And the way that we're going to do that is we're going to specify the group name router that we have specified in our myhosts file. And then we're going to use the -i argument to specify that host file. And then the rest of the command is going to be the same, using the raw module, specifying our command, username Cisco and -k to prompt us for the password. Here's our output. You can see it starts with R3, then it shows R2. So it shows us the EIGRP neighborships for each of the routers. And then the next command that we're going to do is going to be done against all of the hosts that are in the inventory my host file. And then we're just going to be running the show version command. Okay, so here you can see that that's what we're seeing for R4. Switch 1, switch 2, R2, and then R3 as well. So that was successful. So as you can see, filtering through all of that output was extremely cumbersome, which is why we're going to introduce grep filtering here. So I basically took the exact same show version command that we were using here, this ad hoc command that pulls the show version from all the devices. And we're going to add a pipe and then a grep filter onto it. So let's just try this. I'll paste that in there, prompting for the password again, and you can see that it pulls it out. So the reason that we're filtering exactly as we are is because the lines that contain changed also contain the name of the device, and then we know that the next line, since it's processing these one at a time, we know that the line beneath it is going to contain the name of the iOS version for switch 2, for example. That's what I'm looking at right here. And then all the viral images have /0 on the same line as they have the iOS information. And because I made R4 a 3725, it works a little bit different, so we had to look for the line that starts with ROM 3700 software right here in order to get its version information. And so again, the logic of this last part is basically changed or /0 or ROM 3700 software. All right, so with this next ad hoc command, we're basically introducing multiple filters. So the the change that we made here is we're doing a show run piping to include the username, which means that the command that we're actually going to be running against the router is going to be filtered to include only lines that have the username specified in it. And then we're also going to filter that in a similar fashion to what we were doing before and looking for lines that only contained changed or the username. So we're going to run this. And this will quickly allow us to look at all the different devices and make sure that the username command is configured correctly on all the devices, which it is. And with the next command that we have here, we're essentially going to be using the same command and adding another wrinkle to it. By adding this to the end of it, it's going to be storing that output that we see in a file named username.txt. All right, now if you look up here at the network automation device, I've used the command ls from the root directory. And what ls does is it shows you all the files that are right there in that root directory. As you can see right now, there's only the ansible.config in the my host file. All right, so instead of printing all that output to the screen, you can see that we now have a username.txt. So we'll just go cat, which will allow us to look at the file that we have there now. So the output is stored in a file now. All right, so here's a use case that would be pretty useful for troubleshooting. If a user or device isn't getting connectivity for some reason, checking the ARP cache of a network device is a pretty typical troubleshooting step. With this command, we're going to be going out and pulling the ARP tables for all the devices. Okay, so that went out pretty quickly. Pulled everything back. All right, similarly to the show version examples that we had above, scrolling up through all of this output is kind of cumbersome. And let's say that we were trying to make sure that all of the networking devices had the MAC address of our network automation device. In its ARP table, we can take the last 4 digits here and filter for it right here. So copy that, paste that in. And you can see that all of the devices do indeed have that MAC address in their ARP table. Okay, so that pretty much brings to an end what we're going to do with ad hoc commands. Next, we're going to be getting into Ansible playbooks. Also in the next videos, we're going to be blowing away this topology and building some different topologies to work with the playbooks and do some different things with. And if you're getting value out of this, please consider liking and subscribing, and I'll see you in the next video.